if your electric vehicle breaks down on the highway today, there is a 50% chance the culprit is not the massive, futuristic lithium-ion battery sitting under your feet.
No, it's definitely not what most people expect.
Right. It isn't a software crash, and it isn't a fried motor. The thing that actually leaves you stranded on the shoulder of the road is the exact same toaster-sized 12-volt battery that powered your grandfather's old truck.
It is genuinely ironic.
It really is. So welcome to the deep dive. Whether you are already driving an electric vehicle or you're thinking about buying one or you're just insanely curious about how the world is, completely rewiring itself, this session is custom tailored for you.
Yeah, it's a massive shift. We are essentially watching a completely new ecosystem being built from the ground up right now.
And the growing pains are just fascinating.
Oh, absolutely. The logistical hurdles of keeping all these new vehicles moving are so much stranger than people realize.
Exactly our mission today. We want to look way beyond the sleek screens and the cars themselves and really decode the logistical web, keeping them on the road.
We have some great material to go through for this.
We really do. We're pulling from a 2025 deep dive article from Recharged that looks into EV roadside assistance. We've also got this incredibly ambitious municipal charging strategy from the UK's Wokingham Borough Council.
That one is a real eye-opener for local planning.
Yeah, it's wild. And finally, we're looking at a corporate profile of a U.S. company called BeeChargeDev. They are doing some genuinely sci-fi stuff with mobile infrastructure.
It's a great mix of sources.
Okay, let's unpack this, because before we can even talk about rescuing stranded EVs, we have to grasp the macro stage here. Like, what does it take to power all these cars in the first place?
Well, to understand that scale, the Wokingham Borough Council strategy is sort of the perfect microcosm.
Right, because it shows what local governments are actively dealing with.
Exactly. So Wokingham declared a climate emergency, and their big goal is to be carbon neutral by 2030.
Which is coming up fast.
Very fast. And when they looked at their emissions, transport was the second largest emitter. It accounts for 31.2% of their total emissions.
Wow, almost a third.
Yeah. So to hit their climate goals, they forecast a really massive jump in EV adoption. Back in 2020, EVs made up just about 1% of their registered vehicles.
Just 1%.
Right, 1.08% to be exact. But by 2030, they need that to hit roughly 33%.
Wait, a third of all cars in a decade?
Yeah, that's about 40,000 electric cars hitting their local roads.
That is, that's like upgrading the plumbing of an entire city while everyone is simultaneously taking a shower. You can't just plug all those to a regular wall outlet.
No, you absolutely can't. It requires serious infrastructure. They are forecasting a need for 300 and 392 fast charging sockets and another 320 rapid sockets.
Just to keep up with the demand.
Exactly. But here is where it gets interesting. We have to look at where people actually charge these cars.
Right, because I think everyone pictures gas stations. Like, we need a charger on every corner.
But the data shows something else entirely. About 75 to 80% of charging is totally home-based.
People just plug in when they get home from work.
Yep, overnight. And then another 10 to 15% happens at the workplace during the day.
Okay, so that covers almost everything.
It does. Only 5 to 10% is destination charging, like at a grocery store, and a mere 5% is en route, like on a long highway trip.
Okay, wait, I have to push back here for a second.
Sure, go ahead.
If 80% of charging is at home, what about people who don't have driveways? Like, if you live in a terraced house or an apartment, are you just left out of this whole transition?
That is a massive question, and it's actually one of the biggest hurdles councils are trying to solve. Wokingham is tackling this head on.
How so? You can't just run an extension cord across the sidewalk?
No, definitely not. They secured a £173,500 grant from the On-Street Residential Charge Point Scheme, or ORCS.
Okay, to build public street chargers.
Exactly. They're using it to install 38 charge points across 18 residential locations. But it's not just about putting a plug in the ground.
Right, there's a lot of red tape, I imagine.
It's also about accessibility. They have to meet these very strict PAS 1899.2022 standards for disabled users.
Oh, like making sure the cables aren't blocking wheelchairs or the screens are reachable.
Precisely. It is a huge physical and financial undertaking to retrofit these neighborhoods.
And while they're doing all that, I know a lot of people listening are probably wondering about the environmental side.
The whole life carbon impact.
Yeah. Because you always hear these arguments. Isn't EV actually greener when you consider all the mining for the batteries?
It's a very valid concern, and the data from our sources breaks this down quite impartially.
Right. Just looking at the math.
Exactly. At the manufacturing stage, EVs do face major challenges. The mineral processing mining, things like lithium and cobalt, it produces toxic emissions.
So they basically roll off the assembly line with a bigger carbon footprint than a gas car.
They do. They start with a sort of carbon debt, but over the lifespan of the vehicle, the math aggressively shifts.
Because they aren't burning gas every day.
Right. On the UK's current grid, an EV outputs about 65% less greenhouse gas than an equivalent petrol car over its lifetime.
65% is a huge drop.
And it gets better. As the grid gets cleaner, that reduction is projected to hit 76% by 2030.
Okay, so it's a steep upfront cost for a very big long-term payoff. That makes sense.
It does.
So let's pivot back to the driver experience. Councils are building thousands of these permanent chargers, right? And the whole point is to cure range anxiety.
Yes, that famous fear of running out of juice.
But looking at the Recharged article, it seems like range anxiety isn't even what's causing breakdowns.
What's fascinating here is the massive disconnect between what drivers fear and what the statistics actually show.
Because EVs don't break down that often to begin with, right?
Exactly. The data reveals EVs actually break down way less often than gas cars.
Why, how much?
It's about 3.8 breakdowns per 1,000 electric vehicles compared to 9.4 for gas cars.
Wow, so they are more than twice as reliable.
Yeah, far fewer moving parts. But here's the big myth bust. Running completely out of your main battery charge. It accounts for only 1 to 2% of roadside callouts.
1 to 2%. So almost nobody is actually getting stranded because they ran out of range.
Almost nobody. The car gives you so many warnings before that happens.
Right, it'll tell you to pull over, it throttles your speed. So what is the real villain then?
Remember that stat from the intro? 50% of breakdowns are caused by the humble, old-school 12-volt battery dying.
Wait, you're telling me a multi-thousand-dollar piece of futuristic tech is getting brought down by the exact same 12-volt battery my grandpa's old truck uses?
Yes, exactly that battery.
But how? I mean, what does this all mean for the driver? Why doesn't the giant battery in the floor just run the car?
It's a safety mechanism. Think of the main high-voltage battery like a highly secure bank vault.
Okay, a bank vault.
When the car is off, that vault is locked shut by these heavy-duty mechanical switches called contactors.
To keep all that high voltage safely isolated.
Right. And the 12-volt battery, that powers the computer that holds the key to the vault.
Oh, I see where this is going.
Yeah. The 12-volt runs the locks, the screens, and the contactors. If it dies, the computer can't boot up to tell the big battery to turn on.
So the car is just completely bricked. You could have an 80% charge on the main battery, but if the 12-volt is dead, you're not going anywhere.
Precisely. It's a very heavy paperweight at that point.
That is wild. Are there any other mundane reasons they break down?
Oh, definitely. Flat tires are a huge one.
Let me guess, because they don't have spare tires.
Exactly. To save weight, most EVs don't carry a spare. So a flat tire means you need a tow.
That's rough.
And then you get a software faults or people just locking their phone or key fob in the trunk.
It's funny, it's all the boring stuff. So really, the takeaway for you listening is to stop obsessing over charging maps and just check your tire tread and the age of your 12-volt battery.
Yes. Shift your focus from the perceived risk of running out of electrons to the statistical risk of a slow tire leak.
Totally. Okay, so let's say it happens. Your 12-volt dies, or you get a flat and you're stranded. You just call a tow truck, right?
Well, you can, but rescuing an EV introduces a whole new set of dangerous technological hurdles.
Dangerous. How so?
You cannot use a traditional hook and chain tow truck on an EV.
Why not? Like, you can't just drag it by its wheels.
If you drag an EV by its driven wheels, those electric motors act like massive generators. They will spin up and forcefully pump unregulated power back into the car.
Oh, wow. It's like trying to drag a sleeping supercomputer by its power cord. You're going to break something incredibly expensive.
You will destroy the gearboxes and fry the electronics.
That sounds like a nightmare.
And it gets worse. If the tow operator doesn't know what they're doing and tries to jack the car up incorrectly, they can puncture the highly sensitive battery pack underneath.
Which could cause a massive fire.
Exactly. So a flatbed truck and putting the car into a specialized tow mode are absolute necessities.
So you really need someone who knows what they're doing. Which brings us to the corporate profile on BeeChargeDev.
Right. They saw this massive gap in the logistics network.
Yeah, so BeeChargeDev offers a dedicated nationwide EV towing service. They operate in all 50 states, right?
Yes, all 50 states. And they use specialized equipment and safe handling protocols specifically designed for electric vehicles.
But they do more than just towing. Because if you are part of that rare 1% who actually runs out of charge, dragging the car to a station seems so inefficient.
And that's their brilliant alternative, mobile EV charging.
How does that work? Do they just bring a battery to you?
Basically, yeah. They have these vans equipped with massive batteries and generators. They roll right up to your stranded car on the highway.
That is so smart.
And they feed the EV enough direct current, or level 2 power, to get you about 15 to 40 miles of range.
Which is plenty to just let you limp to the nearest public fast charger yourself.
Exactly. You avoid the tow truck entirely.
I love that. But I imagine standard roadside assistance policies aren't all set up for this yet.
This raises an important question about the fine print. You really have to read your policy.
What should people be looking out for?
Well, not all policies are equal. Some have very strict tow distance caps.
Like they'll only tow you 10 miles or something.
Exactly, which isn't helpful if the nearest fast charger is 30 miles away.
Good point. What else?
Out-of-charge exclusions. Some insurance companies view running out of battery as driver negligence.
Oh, wow. So they just refuse to cover the tow at all.
Yep. And you also need to check weight limits. Some of these new electric pickup trucks are incredibly heavy, and a standard tow policy might not cover that weight.
That is such a huge tip. Listeners, literally go check your policies today. Make sure you don't have out-of-charge exclusions.
It could save you a lot of money and stress.
Definitely. Okay, so here's where it gets really interesting to me. If BeeCharged has these vans that can put a charge to a stranded driver on a highway, why limit this to emergencies?
Exactly. Why not use it proactively?
Right. Like, what if this mobility is the answer to those grid constraints we talked about with Wokingham Borough Council?
That is exactly what BeeCharged EV is doing. They are deploying this mobile EV infrastructure to high-demand areas.
Like where? Commercial buildings.
Commercial buildings, large retail centers, massive event venues.
Places where installing a permanent charger is just too expensive or complicated.
Right. You completely bypass the need for expensive permanent groundwork that local governments are struggling with.
That makes so much sense. If there's a huge concert, you don't need to build 50 permanent chargers that sit empty the rest of the week. You just bring the vans in.
Exactly. Infrastructure on demand. They even offer an elite membership program now.
Oh, really? For individual drivers?
Yeah. They have over 1,500 members who get priority charging and dedicated support.
That's a great safety net. But the part of their profile that blew my mind is the autonomous stuff.
Yes, their groundbreaking initiative.
They are working to become the first autonomous EV mobile charging company in the U.S., right?
That's the goal. Self-driving charging units that physically navigate to your vehicle without a human operator.
Just requested via a simple app. Imagine being at a crowded concert. You just tap a button on your phone, and a giant autonomous battery wheels itself over to your car.
It's incredible technology.
It's like an automated pizza delivery, but for electricity.
That's a great way to picture it. And if we connect this to the bigger picture we've been talking about, it bridges the gap perfectly.
How so?
Well, it solves the local council's problem of permanent infrastructure limits, because the chargers aren't tied to the ground.
Right.
And it solves the driver's problem of roadside vulnerability because the power comes to you.
It totally changes the paradigm. So for you listening, let's wrap our arms around this whole journey. We started with Wokingham's ambitious goal of hitting 40,000 EVs by 2030 and the massive grid upgrades that requires.
And the very real whole-life carbon benefits that make that effort worth it.
Exactly. Then we found out the surprising truth. Range anxiety is basically a myth, and a basic 12-volt battery is actually your biggest roadside threat.
Which is still hard to believe.
It really is. And we learned that if you do break down, you have to demand a flatbed tow truck so you don't destroy your car. And now we're looking at a future with self-driving charging bots.
It's moving so fast.
So, practically speaking, go check your 12-volt battery, read the fine print on your roadside policy, and demand that flatbed.
Those are the best immediate takeaways.
But before we go, I know you always have an eye on the horizon. Where does this technology go from here?
Well, we've seen that infrastructure is becoming entirely mobile, right?
Yeah, taking the charger to the car.
As battery technology improves and autonomous systems scale up, it raises a wild possibility. What happens when our vehicles eventually just charge each other on the go?
Wait, really? Like while you're driving?
Yeah, through vehicle-to-vehicle wireless transfers. Imagine a truck just transferring power to your car while you're both doing 60 on the highway. Will the entire concept of a stationary charging station become completely obsolete in our lifetime?
Wow. That is definitely something for all of us to mull over today. Thank you so much for joining us on this deep dive into the sources. We hope we prove that staying well-informed about our rapidly rewiring world doesn't have to be overwhelming. Have a great day, and we'll catch you on the next deep dive.